Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 12, Section 10, Probability of Composite Events. A composite event consists of two or more simple events. Now, we've discussed in previous videos how to find the probability of a simple event. If there are 2 green marbles in a bag of 8 marbles, then you have a 2 out of 8 chance to pick the green marbles. That's a simple event. Okay? There are a total of 8 marbles. 2 of them are green, so you have a 2 out of 8 or a 1 in 4 chance of picking a marble that is green. You take the favorable outcome and you put it over the overall possible outcomes. There is a possibility when I reach into that bag of pulling out 8 different marbles, but I'm only looking for 2. So today we're going to be taking a look at composite events, which is finding the probability of 2 simple events. So there are 3 different situations that could occur. We could have an independent event, a dependent event, or a mutually exclusive event, all of which require you to approach the problem slightly differently. In an independent event, if we're going back to the marble example, okay, let's say we have 8 marbles again. And let's say there are 2 green, we have 4 blue, and we have 2 red in this bag. In an independent event, and this is what this video is going to be on, it's going to be on finding the probability of independent events. In an independent event, the outcome of one event does not influence the outcome of a second event. So if I were to pull a marble, and I am looking for a green marble, I have a 2 out of 8 chance. After I pull that green marble out, if I get green, I am going to put it back in the bag. So that way when I go to do my second pull, or when I go to exact my second simple event, the chances are still the same. My first pull has not affected my second pull because I'm taking the marble from the first pull and putting it back into the bag. So both events are independent of one another. Okay? So let's say I would like to know the probability of pulling 1 green and 1 blue. Okay? What I am going to do is I'm going to find the probability for each event individually. So I'm going to find what is the probability to pull 1 green out. I have a 2 out of 4 chance. Or 2 out of 8, I'm sorry. There are 8 total marbles. And there are 2 green marbles. So there's a 2 out of 8 chance to pull a green marble. There is a 4 out of 8 chance to pull a blue marble. So now I have found the simple probability for each of the independent events. I now want to know what is the total probability of pulling a green marble and a blue marble. Doesn't have to be green first. It's just simply I'm going to at some point pull a blue and then pull a green, or pull a green and then a blue, as long as I get both colors. So I have 2 pulls and I want to pull a green and a blue. What is the probability of that? At this point, in order to find the probability of that, I would have to multiply these 2 simple probabilities together. And some of us may be asking, why do you multiply those 2 things together? And we would end up getting an 8 out of 56 chance. Or, if you reduce it, it becomes a 1 in 7 chance. So, why does this work? Up top represents my favorable outcomes. Down bottom represents the total outcomes, total possible outcomes. By multiplying 2 times 4, what I am doing is I am saying that there are a total of 8 different possible outcomes where I could pull a blue and a green marble. I could pull, so there are 2 green marbles. Let's name them green marble A and green marble B. I could pull green marble A, and then I could pull any of the 4 blue marbles. So there's 4 possible outcomes. I could then pull green marble B, and then I could pull any of the 4 blue marbles. So there's another 4 possible outcomes where it is favorable to me. There are 8 favorable total. There are 8 favorable possible ways to get green and blue. Like I said, I could get green marble A, and I could then proceed to choose, match that up with blue 1, blue 2, blue 3, or blue 4. I could also match up green marble B with any of the 4 blues as well for a total of 8 possible ways to get a green and a blue. So I could have green A and blue 1, green A, blue 2, green A, blue 3, green A, blue 4. Or I could have green B, blue 1, green B, blue 2, green B, blue 3, green B, blue 4. All of those would work. And it doesn't matter if I choose blue 4 or green A first, or green A or blue 4 first. Those don't count as separate because order doesn't matter. I don't have to pull a green first. So there's a total of 8 possible ways to pull a green marble with a blue marble. Now, since there are 8 marbles in the bag during both pulls, there's a total of, that should not be 56. That should be 64. This is your math teacher. There are a total of 64 different ways to pull 2 marbles out. So the first pull, you have 8 options. And the second pull, you have 8 options. So there's a total of 64 different possible outcomes for pulling 2 marbles out of that bag. That could be favorable, they could not be favorable. There's a total of 64 possible outcomes, period. So as you can tell, this is relying heavily on the previous chapters. We're using permutations and combinations here. Specifically, we're using permutations in this instance. We're finding all the different permutations of pulling 2 and then 4. And we're finding all the permutations of an 8 and 8. Okay, so we have 8 on the first pull, we have 8 on the second pull, so all the different possible outcomes, chapter 12, section 8, okay, is 64 total. Because I can take I can take marble 1 and match it up with 1, 2, 3, 4, 5, 6, 7, 8 different marbles from pull 2. I can then take marble 2 from pull 1 and match that up with any of the 8 from pull. Match that up with any of the 8 from pull 2. I can then take marble 3 from pull 1 and match that up with any of the 8 from pull 2. And so that's why this works. Okay? So what we have over here in this 8 over 64, this is the total possible outcomes over the total possible favorable outcomes. Like I said, green marble A can be matched up with any of the 4 blues. Green marble B can be matched up with any of the 4 blues for a total of 8 favorable outcomes. Total number of outcomes is on bottom. This is the way fractions work. Whole is on bottom. Okay? Part is on top. The part is what I'm looking for. The piece is what I'm looking for. Okay? These are my favorable outcomes. The bottom is just every possible outcome imaginable. Okay? So, again, pause the video, take some notes. But all you do is you take the simple probability for the first pull and the simple probability for the second pull, and you multiply them together. And I explained why that works. If you have any questions, let me know. In the next video, we'll be talking about dependent events, which are very, very similar. We've actually pretty much done them before, and I will explain them. They function in the same exact way. You're going to be multiplying two probabilities together. Why that works is the same explanation I just gave you, but we'll talk more about that in the next video.